Hi everyone, today we're going to continue with redox and we're going to look specifically into oxidation state for this lesson. Now, so oxidation state or oxidation number refers to a real charge in the case of ions or imaginary charge if we are talking about covalent compound. So in an ion, it is just a charge on the ion, but in covalent compound, it is an imaginary charge that we talk about. Now, in order to find out about oxidation state, we need to remember some rules. So these rules are important in helping us find out the oxidation state of some elements that we need to check for. So rule number 1, all uncombined elements have oxidation state of 0. So anything you can find on your periodic table together with things like nitrogen, hydrogen, oxygen, things like this, they are all elements, so their oxidation state would be 0. Okay? Rule number 2, the oxidation state of an ion is just the charge on an ion. For example, on sodium ion, the oxidation state would be positive 1. Oxidation state would be positive 1. Okay? Now, rule number 3 is related to hydrogen. So hydrogen, depending on which type of element it is bonded to, has got different oxidation state. So when it is bonded to a metal, hydrogen will have an oxidation state of -1. But when it is bonded to a non-metal, okay, its oxidation state will be +1. Now, the next rule is related to oxygen. Now, oxygen, in most cases, have an oxidation state of -2 in all other compounds, okay, in most cases. The only exception is when you see the word hydrogen peroxide. So in hydrogen peroxide, the oxidation state of oxygen is -1 instead. So other than hydrogen peroxide, the oxidation state of oxygen in all other compounds is -2. Okay? Now, in ionic compound, the oxidation state of the element is just the charge on and off end of the ion. So, for example, in sodium chloride, sodium is +1 and chloride is -1. So it's just a charge on the ion. Now, how do we find the oxidation state of an element in a compound? Okay, first rule, for a compound, the sum of all the oxidation state of all the elements is 0. So let's look at one example. Okay, if I'm asked to find the oxidation state of chlorine inside Cl2O3, step 1, I write down the oxidation state of whatever element that I know of based on the rules. So from the rules, I know that oxidation state of oxygen is -2. Okay, so from the rules, the oxidation state of oxygen is -2. Now in step 2, we let X be the oxidation state of the unknown that you want to look for. So in this case, it will be chlorine. So I let oxidation state of chlorine be X. So then I form an expression, an algebraic expression to solve for my X. So basically, Cl2O3, right? So you have 2 of Cl, so 2 times of X plus 3 times of -2. Okay, why 3 times of -2? Because I have 3 oxygen and each one has got an oxidation state of -2. Okay, and the sum of all the oxidation state will be equal to 0. That's why it is equal to 0 here. And if I solve this algebraic equation or algebraic expression, the answer will be positive 3. Therefore, my oxidation state of chlorine is positive 3. Okay? Now, for a polyatomic ion, what are polyatomic ions? Some of the examples of polyatomic ions would be your NO3 minus, your SO42 minus, an ion with more than one type of atom. Okay, so this is just example. Now, for polyatomic ion, the sum of all the oxidation state will be equal to the charge on the ion. Let's look at one specific example. If I want to look for the oxidation state of manganese in MnO4 minus, same thing, step 1, I write down the oxidation state of whatever elements I know based on the rules. Okay, so my oxidation state of oxygen is -2. I already know this. And step 2, I let the unknown oxidation state be X. So the unknown here is oxidation state of Mn. That's why I let X be the oxidation state of Mn. And I form an algebraic expression. So I have 1 Mn in MnO4 minus, so X plus 4 times of -2, 4 times of -2 because there is 4 oxygen atom, okay, 4 oxygen atom here, and each oxygen atom has got a oxidation state of -2, and I equate them to -1 because the charge on the overall ion is -1. So the sum of all the oxidation state of all the elements will be equal to the charge on the ion. Okay, so I solve this algebraic expression, I get my answer. The oxidation state of Mn is +7. Now let us look at one example to help us understand this better. In this example, you are expected to find the oxidation state of chromium in K2Cr2O7. K2Cr2O7 is your potassium dichromate 6. Okay, potassium dichromate 6. Now, there are two methods. Let's look at the first method. In method 1, we consider it as Cr2O7 2 minus. Okay, we take out the ion. We only consider the ion because K is +1 because it's in group 1, right? So you need 2 potassium to balance, so Cr2O7 would be 2 minus. I know that my oxidation state of oxygen is -2, so that's something I know, I write it down. And I've let the oxidation state of what I want to find be X, the unknown be X. And here I then form an algebraic expression. So I have 7 times of -2, -2 because each oxygen has got an oxidation state of -2. Okay, so this is the oxidation state of oxygen, and I have 7 of them. And if I add 2x, because I have 2 chromium here, the charge would be equals to -2 because dichromate is -2. And if you solve the algebraic expression, X would be +6. Therefore, the oxidation state of chromium in Cr2O7 2 minus is +6. That is why the name of this compound is called potassium dichromate 6. Now in method 2, right, I write down the oxidation state of oxygen, which is -2, and I write down the oxidation state of potassium, which is +1. And I also can form an algebraic expression, so including the potassium. So 2 times of +1, because this is the oxidation state of potassium, and 7 times of -2, because this is the oxidation state of oxygen, plus 2x because I have two chromium ions, and the entire thing, you sum them up together, it will be equals to 0 because the sum of all the oxidation states of all the elements is 0 in a compound. If you solve it, I will still get positive 6. So oxidation state of chromium in dichromate is positive 6. So it doesn't matter which method you use, both are acceptable. Now, I would like you to try some of them on your own. You can write them down on a piece of paper. Right? So right now, I would like you to pause to try out this 7 question. And after you have completed them, you can resume the video and you will see the answer in the next part. Okay, so pause now, try, and then you can check your answer after that. I hope you have done all 7 of them. The answers are there, written in yellow. So please check your answer. And that's the end for this segment. Thank you.